Very good morning, friends. I welcome you all to my YouTube channel. And in today's session, we have a special problem on a lamina. That is, we are considering the projection of a lamina which is in the shape of a rhombus. So, as you know, this rhombus will have the opposite sides parallel and equal, and the opposite angles as an angle B is equal to angle D, angle A is equal to this one. So in today's session, let's see the statement of a problem given. A lamina in the shape of a rhombus with a diagonals 40, 80. The shorter diagonal BD is 40. This is 80. It appears as a square in the top view. So we have to place this on the HP so that it has to appear as a square in the top view. So friends, if you place this lamina on HP with the longer diagonal parallel to VP, and if you slowly lift it up for a particular angle, the surface making with HP, you get a square in the top view when the diagonal BD, which has got a length 40 mm, becomes equal to the length AC, which is also 40. Because in a square, all the four sides are equal and the diagonals will also have the same dimension. But by mistake, if you keep the lamina like this, with the shorter diagonal parallel to, and if you just keep rotating this about that corner like this rhombus will never become a square. So that's why you have to be very careful while initially placing the object on HP or on VP. So friends, it is confirmed that we have to keep the lamina on HP with one of the corner coming to your left hand and the longer edge being parallel to VP and HP. So friends, let me write down the top view, a rhombus having diagonal 40 by 80 and the front view a line on XY. So I will call this as ABCD. This is A, B, C and this is D. And here friends, the shorter diagonal measures 40 mm and the longer diagonal AC measures 80 mm, 80 millimeter. So by projecting points from all these corners A, B, C and D onto XY, you get a line on XY which is represented by, so let's call this by small letters A, B, C, D instead of capital. So this is small a, B, C and this is D. And in the front view, you get a line on XY which will have a dimension equal to length of the longer diagonal. So we'll call this point as A dash. This middle point becomes B dash, D dash and the last point is C dash. So when the lamina is placed on HP with a longer diagonal parallel to VP, you are going to get the front view a line and I will call the length of this line as usual as M. M represents the length of the front view of the lamina, which is equal to 80 millimeter in this case. So friends, we have got the front view and top view of the rhombus, which is measuring 80 by 40. Now he says, friends, while resting on a corner on HP, it appears as a square in the top view. So we had this like this. Slowly I am going to move it upwards with corner A on HP such that for particular value of theta, only one value of theta, it becomes a square. How does it become a square? The shorter diagonal is perpendicular to VP. It will never change in its length. Whereas the longer diagonal, depending on the inclination the surface is making with HP, keeps on decreasing. And a particular value of theta, this AC becomes equal to BD. That is, both the diagonals will become equal or appear to be equal, in which case the top view becomes a square. And very obviously he has given it has to appear as a square in the top view. So adjacent to this figure, the top view you have got, I am going to get a square with all the sides equal. So I will have a square here, and all the sides of the square will be same, and all this will measure 40 millimeter each. So this is 40. So when this is 40, this will also be 40, and all the sides will become equal to 40. So we will call this as A, this is B, C, and this is D. Friends, they have given the top view is a square. Let us get what is the corresponding front view of this lamina. So you will project these points one by one. The position of A is fixed. It has to be on HP. So I just write a vertical line from here and fix the position of this A dash, the front view of that corner. And how to get this corner C? I will write a vertical line from here, that is a line through this corner. Now friends, you know very well, in any of these lamina, the front view in the case 1 and case 2 will have the same length. That is in step number 1 and step number 2. What I do, I take A dash as center and M, which is equal to 80 millimeter, I just strike an arc. So as to get the vertical line drawn through C at point C dash. So I am going to join A dash and C dash, and this line will represent along with this B and D, which is exactly in the center, that is B dash D dash. This will give you the front view of the lamina, which will be making an angle theta with HP. So you will be able to measure for what value of this theta this appears as a square in the top view. Friends, we have got the front view, you have got the top view. And in the third stage it tells, uh, so draw the as a square in the top view with longer diagonal appearing normal to VP. The longer diagonal is what is AC. That AC is here. This AC, whatever you have got here, is parallel to VP. AC parallel to VP because parallel to XY. But it has to be just to appear normal to VP. So what we do finally, whatever the top view we have got here, we are going to redraw such that the side AC which is parallel to VP becomes perpendicular to VP. So friends, again adjacent to this or anywhere here, we can draw another square, a similar square with the same dimension. So I am going to get another square here, but the condition is here the line AC which was parallel should become perpendicular. So this we can call it as A, B, C and D. This A, B, C, D, wherein this AC which was parallel to VP has become perpendicular to VP, and we should get the corresponding front view for this. So this figure square will give you the final top view of the lamina, corresponding to which we are going to get the front view. So how to get the front view? Friends, as usual, start from one of the corners and draw the projectors both vertical and horizontal. So I will draw a vertical line through a horizontal line through A, the point where these two intersect, will be the point A dash. So I will call it as A dash here. Likewise, B, vertical from B, horizontal from B. I'm going to write a vertical here, a horizontal. The point where those two intersect is the point B or B dash. Similarly, C, vertical from C, horizontal from C. The point of intersection of these two will give you the point C dash. Finally, D, horizontal from D, vertical from D. So they will meet here at this point. So friends, you have got all the four corners, A dash, B dash, C dash and D dash. Join all these by straight line. So I am going to join C to D, C to B, C to A and D to A. Friends, this figure A dash, B dash, C dash, D dash will represent the final front view of the lamina, and this will give you the final top view. And you can see friends, since the point or the corner A is on HP, it is seen as A dash in the front view on the XY line, and the shorter diagonal, sorry, the longer diagonal AC which was parallel is appearing normal to VP, and hence in this condition it is satisfying all the requirements of the question, and the solution whatever we have here is completely correct. Thank you friends for watching my TV.